Hello guys, welcome, and today I'm going to show you all how to build a model to predict the cancer and stages of cancer. So in my project now I'm going to take you all step by step of how I built a model and how you can build a model and you can improve it. And please improve this model and let me know. So let's get started with the project, and the link will be in the description, and also the link for the dataset will be available within the project. Please do check out. Okay, let's get started guys. Come on.
Cancer prediction using gene expression data. So here you can see that we have used gene expression data. Gene expression data is the process by which a gene gets turned into a cell to make RNA and protein. Or you can tell it as information from a gene is used to synthesize of a function gene product that enables end products such as protein or RNA. Okay, I think you can just understand this by this basic concept that gene expression data is the something a data which is taken by the gene by its ability to produce end products like RNA and protein. Okay, so here the required libraries which we have used is NumPy, Matplotlib, Seaborn, Pandas, and this is actually sklearn. Okay, so here we have imported the libraries. Actually, you know what, while building the model, actually we add the libraries in the particular place for a better understanding, but here I have done everything in one beginning so that you will understand. Import pandas as PD. Okay, pandas is a library used for importing data sets and also used for analysis, basic analysis and data manipulation. NumPy is used for array calculations, and then this is for data visualization. Matplotlib, it is used for data visualization, and Seaborn is used for advanced data visualization. Okay, so this is as PD, means short form PD. Okay, instead of typing full pandas you can just type PD. Okay, so import pandas, we have imported pandas as PD, which is short form. Okay, so this everything is done the same way till here, and then this is for preprocessing. Okay, this is preprocessing in the sense something like making your data in a proper way in which machine can take it and understand it and then use it for machine learning. Test, train, and split. It's something which splits your data into training dataset and testing dataset. Okay, for example, you're going to write an exam. So when you're writing an exam, before the exam you start studying. Okay, you study the 90% of the portions, and then the 10% of the portions which you studied will be in exam. Or else something like you study one book, and from that one book maybe 20 questions will be asked in exam, something like that. So we are splitting the data into train data and test data. Okay, and this is used for that splitting. And then label encoder. In label encoding in Python, we replace the categorical values with the numerical values between 0 and a number of classes minus 1, which is like for example 0 to n minus 1. Okay, because it starts from 0. So if you have 10 categorical values, it will be considered as 9 values from 0. Okay, it's basic, you can understand this, because in Python most of the cases it starts from 0. So label encoder, for example, why we use label encoder here is computer algorithms only understand numeric values. Okay, in case we have non-numeric values, we have to convert the non-numeric values to numeric values so that the machine will understand it. Okay, it's not we can understand anything, but for a machine to understand, it processes in terms of numbers. Okay, so numeric values. So we use all this one for numeric values, and this is for binarization. Okay, converting binarization is making your data more categorical, like high, low, medium, something like that. You can binarize the data. Okay, and min max scalar is to normalize the data. Normalize the data is nothing but if you have 100 numbers in 10 if you have 100 random numbers, you can scale all the 100 random numbers between 0 and 1. Okay, that is called normalization. Okay, there's one more called standardization also, which also goes from negative to positive. We'll talk about it later. Okay? And future selection. Future selection, we use mutual info classifier. Okay, which gives us the mutual information between the matrix containing a set or of future vector and the target. So classification, this is the model. Okay, these are the models which are going to use. So this one is used for random forest classifier, and one versus rest classifier. We want to do a multi-class or a multi-label classification, and it strategy consists of fitting one class per class one classifier per class. Then we use one versus rest. Okay, fitting one for others, everything in the same way. But the random forest is an individual algorithm. Random forest category creates a set of decision trees from randomly selected subjects for training sets. Okay, if then the votes it votes for different decision tree, and which decision tree weights more, it just shows that first. So it just it's in the more in the into voting session. Okay, it votes. Okay, and then these are the parameters used for testing the accuracy and the functionality, prediction, the ability to predict the accuracy, the score, and comparing all of them. So F1 score represents the moral score, or as a function or a precision and recall score. Okay, this is used to measure the model. Okay, in the scenarios where one tries to optimize either. Okay, or just in simple ways comparison of with one another. Okay, and then ROC curve, this creates a report, classification report. I will be showing you later. If here some things will be understood when I show you guys, so I'll be showing you very soon. Okay, and then ROC curve in Python, it's something like one way to visualize the two matrices between the ROC curve. ROC stands for receiver operating characteristics curve. Okay, so just plotting one against the other. Okay, so I'll see. So this is the reading data. We use pandas here, PD. So this is okay, and very important one is data sets. You get the data sets from here, which is the live data. Okay, and read data. This gives us the ability to read the data. Okay, this is the zip file which I've downloaded from this website. You can download that. It's a biological, many things are there related to biology, and specifically you can download this link. Okay, in the data sets only there are so many categories, but gene expression for cancer is the one which we have taken. So here we are reading the file. Okay, file URL. So we are putting the zip file into the file URL and then reading it using read CSV. Okay, because the zip file has the CSV file in it, so we are reading it. So this one is stored in data frame. So this is the head which gives five top this thing. See here, you can see there's a numeric value. So cancer type is numeric, no, non-numeric, sorry. So non-numeric in the sense this one should be converted to numeric. Okay, rest everything is in numeric. Maybe we have to normalize it between 0 and 1. Okay, so here this is 5 rows. Actually there are many rows, but this head default gives us 5 rows. And then we have 8001 column. Okay, it's a lot of columns actually. Dataframe.info, this gives us the information of the data frame. For example, we have 801 entities, which are 801 rows, and 801 entities as columns. So 801 rows and 801 columns, 8001 columns. Okay, and data types includes float and object. So that means everything is in float, and this one is in object type. Okay, so describe gives us all the description of min, max, and standard deviation, and mean is nothing but an average, and the count values. Okay, so 801 rows. So here we have so many, we have 8001 columns. Here you can see 8000 columns, Why it was showing 8 not one column is the indexing in Python starts from 0. Okay, so maybe here it's showing from 0. Okay, 0 to 8 not 8000. Okay, if it comes to 1, 1 minus 1, 1 plus it comes, so it becomes 8001. Okay, and cleaning the data set. So let's see this. See, I just explain. We will get to know this data within the first few EDA, exploratory data analysis. So here we have 801 rows and 8001 column, and data frame columns gives us all the columns. Not exactly all, but you can store everything. Actually, in Spider you can see this clearly, but in Jupyter Notebook you can just see it like this. Okay, so this again gives us the columns from 0 to 3 index. Okay, so -1, this one in index, this is a list format. It gives the last column. Okay, so data frame.column shows us this type, cancer type, which is our main target. Okay, we should predict which type of cancer it is based on the values which we get. So this is the beginning. Okay, so now here what we are doing is we are creating a user defined function. This is a user defined function for checking the missing values. Okay, checking the null values. So we get 0 null values. So anyways, the data, everything is full. So if in case we get any null values, we use imputations, something like mean imputation, median imputation, or mode imputation. So here these are the types. Okay, value.counts gives us how many types of the values are there in one particular column. Okay, here in this column we have BRCA, which is 300, which is breast cancer, and KIRC, which is kidney cancer, LUAD, which is lung cancer, PRAD, which is prostate cancer, and COAD, which is colon cancer. Okay, so here we have 5 cancers. And now plotting a bar graph, we can see this in bar graph. So here we have 300 values. So these are the value counts. Here for breast cancer we have 300. Here it's almost 150. Is it 150? Yeah, 146. So this is a rough diagram. Okay, you can plot many things. Actually you should be doing this more. It's called exploratory data analysis. So here we are dividing the data X and Y. Okay, X has all the data sets excluding the last column, which is the prediction column. Okay, this is the source. Using this we will predict the Y. Okay, and Y is the target variable. Okay, so this Y includes the last column only. Here we can see that we have printed head, x.head, which shows us every column except the last one. 8000 columns, 8001 column is missing. The one column is in Y. You can see here. Okay, this we have divided into X and Y. Okay, so first division is done by separating the target variable with the source variable. Okay, now next is label encode. Okay, or encode labels, which is converting of these labels into numeric values. For example, breast cancer, colon cancer, kidney, liver, and prostate is converted to 0, 1, 2, 3, 4. Okay, all are integer type. So this is what we are focused on mostly. Okay, now data splitting. So as I've explained you before, we are splitting the data. We are splitting all this X and Y to 80 and 20%. Okay, 80% will be the training data and 20% will be the testing data. So here we have described the data frame. So this gives us all the only 10 description of the data. This is not needed actually, but for a brief you need to have this. And normalization of data. Normalization of data comes to fit all the data into the scale of 0 and 1 so that our prediction will be more accurate. we do future selection here using multi-info classify. Okay, so this one gives us the mutual information between the matrix. So we are fitting the model X train and Y train. Okay, so these are the training. We are using 641 for 40 columns and rows for training, and then 161 for testing. Okay, now let's do classification model. Okay, here we are using random forest classifier. So this random forest classifier, you can find it, as I have told, it is the most used and more accurate and more fast. So random forest is being used with the help of one versus rest classifier. So we are fitting the model here. Okay, predict. So we are predicting the model, and now model evaluation. So model evaluation gives us the accuracy of the model, or how accurate the model is, like the precision, like what is the true value it has predicted, what is the negative value it has predicted. There actually it has a matrix which is true, positive, and negative, false, negative, true, positive, true, false. Okay, we'll see this. It has four corners, which is true and true, false and false, true and false, and false and true. Okay, so this is the precision. It's in total it comes around 92%, 91%. Okay, so precision is 92%, which is actually good. We have done a good fitting here. Actually, we can try out many different models, but this is actually good. We can try out with this. This is the individual score. Okay, individual score of the precision. See, for example, breast cancer has the 95, which is not the highest, but then prostate cancer has the highest score. Okay, breast cancer as the second, and then comes colon, and then liver and kidney. Okay, so this is the overfitting in precision. Okay, exact prediction. Fine, let's see different things. Okay, this is the confusion matrix. So confusion matrix tells us the prediction of true, negative, true, positive, positive, negative, and false positive, false negative. Okay, so this has four corners, as I told you. So the center thing you can see here is the actual prediction. Okay, and these at the left and right, you can see that only living except the diagonals, you can see other values might be the false values, totally false values. Okay, so this is 56, which is actually breast cancer, I guess. Yeah, breast cancer is BRC, which is here, and this comes to colon cancer prediction, and we get 33 in prostate, because the data is low. You can see the data sets, the count value is low for prostate, and for breast cancer it is more. Okay, so it is breast cancer it is more, and for colon cancer it is less. So the accuracy is be more. Actually, the accuracy for prostate cancer is more actually compared to breast cancer. That's why it's showing like this. The precision score is very accurate. So this is the heat map. So you can see the prediction here. This is the prediction, and these are the false values. Okay, these are the true values. This is given us the highest values. This highest true values. Okay, and the next comes the last. So 56 is breast cancer, and then 33 is prostate cancer. Okay, so the next one is the ROC curve. Okay, so I have explained you this. Actually, our model building is done. Now the ROC curve, which the ROC curves is nothing but I have told you that it is receive operating characteristics. Okay, this one just displays the sensitivity and the specificity of a logic regression model. Okay, so this model is being plotted. So this is the plot which we get at final. Okay, and the next step after this is the deployment stage,